Okay, the last section in Unit 2 is about graphing complex numbers. So I gave you a small look into it, and it's right here. So remember, the x-axis is really the real axis, and the y-axis is now the imaginary axis. So if we want to graph these points and label them with the letters, so we've got 7 is real, so 1, 2, 3, 4, 5, 6, 7, and then 3 in the imaginary direction, which is up. So that's A. B, -2, -4, 1, 2, 3, 4. C is 3, so we're going to go 1, 2, 3, and then we don't go any in the imaginary direction. And then 0 is the real, and so up 1, 2, 3, 4, 5 in the imaginary. And that would be graphing. So as a bonus, I said, which of the following points is the farthest from the origin? So it's definitely not C, but D, A, and B all kind of look close. So remember, distance is known as the modulus. It's the absolute value. So let's look at A. So the square root of 7 squared plus 3 squared. B is -2 squared plus -4 squared. And C, we said nah. And then D, 0 and 5. So what do we have here? 49 plus 9. 4 plus 16, and 25. So obviously A is the winner. And you might have guessed that by looking, but that's how we would actually find out and justify it. Okay? So next we're going to find, it's called the argument. So we're going to start a little trig intro, but the argument, it's the angle that's formed with the positive side of the real axis. So the positive side, remember the real axis is the x-axis. So I would be looking for the angle of the argument of z. So what angle we make with respect to this real axis. So really it's going to be between 0 and 180. And it's the positive side. So from here, so start. Okay, so you can kind of think of this as like 0 degrees. So to get that, most of your calculators or even the internet calculator, it's called inverse tangent. So this is a formula. You're going to take the imaginary value over the real value. And we're going to do this in degrees, okay? So make sure that your calculators are in degrees. So I like to plot it to see if the answer makes sense. But look at the pictures. If we go up, it's going to be positive angle, and if we go down, it's going to be a negative angle. But your calculator will give that to you. So let's do a couple of examples, and it sounds a lot harder than what it really is. So if we want to find the argument, and I'm going to graph it just to kind of help check ourselves. So we go 5 and then up 7. So I would be looking for, from the positive side, I'm looking for this. So I've got inverse tangent, and let's scroll up, of the imaginary over the real. So the imaginary is 7, and the real part is 5. Okay, so I'm going to just bring up a calculator on the screen. So we're going to do inverse tangent of 7 divided by 5. I think I can even do this. And we'll do degrees. So that, it says radians, but yep, it's the same thing. So 16.37. So I did a bad drawing, but, and I'm just going to go to 2 decimal places. So we'll do the same thing here. So 1 and then minus 2. This will be a better drawing. So we want from the start, so we went down, so it should be a negative angle. So we've got inverse tangent of the imaginary over the real. So we'll go back to my calculator. Okay, and I'm just going to do this. So negative 2 divided by 1. And look, see, it's negative 63.43. And that makes sense. So even if you don't have your own calculator, just make sure you tell it what to do, like you saw me type in. So the last example, if you want it, would be negative 6. 1, 2, 3, 4, 5, 6, and then up 3. I'm trying to make this accurate so we can see if our estimate's pretty good. So this one should be an obtuse angle. Okay, so I'd have to guess, I'm going to guess about 150, but I'm also a terrible guesser. So the real part over, I'm sorry, imaginary over the real. At least I wrote it right. I just don't always talk right. Negative 3 over 6. So negative 3, and it doesn't matter if you put the negative on top or bottom. So negative, notice how we have this negative 11, which we know is not correct. So that's going to be that reference angle. This is going to be our 11.36. And I know it said negative, but that's what was left. Let's see, was I right? Oops, sorry, 11.92. 11.93. So then if I take that off 180, I get 168.07. And we can check it. So 168.07. If I type in tangent of 168.07, I don't know where my answer went. Yes, I did mean that. I thought I was going to find it. Well, it didn't find it, but trust me, I'm okay. All right, so sometimes you have to look at the picture. Like without a picture, I wouldn't have known that. But with the picture, then I can do some calculating. All right, so you give it a go and let me know what issues you have.